right, let's dive a little deeper into infinite limits. So remember, an infinite limit is just asking about a vertical asymptote. So it's saying, what value makes this function go to infinity or negative infinity? So we looked at the other one in the last video, and we saw it has a vertical asymptote at 2. And we looked from the right side and said that it's going to positive infinity. Now let's look from the left side. Since we know it's an odd vertical asymptote, we know that it has to be going to negative infinity. That's just intuition. But let's see what that looks like with algebra. So we're going to do sign analysis again. So we're going to say, okay, when x equals something just a little bit smaller than 2, right? Because we're approaching from the left. So that's going to be something like 1.9. We're going to see what the signs are when we have 1.9. Okay, well, 1.9 plus 3 is still going to be a positive number, right? As I get closer and closer to 2. Even if I did 1.9999 plus 3, right? That's still going to be a positive number, okay? So I have a positive number on top, and then I have 1.9 minus 2. And when I subtract that, I get a negative number, right? Because I get a negative 0.01. So what this tells me is that this is becoming a huge number, remember, because it's a normal size number divided by a tiny, tiny number, which gives us a huge number. So I'm going to get a huge number, which is infinity. But I'm going to have a positive divided by a negative, which is negative, which means as this one approaches 2 from the left side, I am going to negative infinity. Let's take a look at this one. So again, we check for vertical asymptotes and holes. We see that nothing cancels out. So since nothing cancels out, we just know there's a vertical asymptote at 1. And we know that that's going to be an even vertical asymptote because the power of the factor that created the vertical asymptote is 2, right? It's an even power. So we know that we're going to have an even vertical asymptote. So we know it's either going to both go up or both go down. Okay, so now we just have to figure out which way is it going. So we approach this, we're talking about numbers that are just slightly bigger than 1. That's what that plus sign means. So let's put a number in that's just slightly bigger than 1. So like 1.1 minus 2 over 1.1 minus 1 squared. So what's going to happen to the signs here? Well, 1.1 minus 2 is going to be negative because that's, smaller. 1.1 is smaller. Even if I did 1.01, 1.0001, any of those, still going to be smaller. And 1.1 minus 1 is going to be a positive number, but it doesn't really matter because it's squared. So it's always going to be a positive number, right? So it doesn't really matter what number I have here. It's squared, it's going to be positive. So I'm going to have a negative over a positive. So again, I've got a normal size number divided by a tiny number, which gives me a huge number. So that gives me infinity. And then is it going to give me a positive or a negative infinity? Well, the sign analysis tells me that it's going to be a negative divided by a positive, which is a negative. All right, let's look at number 4. We're looking from the other side now. Remember, we had a vertical asymptote at x equals 1. We knew it's even, and the last one went to negative infinity. So intuition tells us this one should also go to negative infinity because it's an even asymptote, but let's just check to make sure, just in case you're curious. If we're going to take a number that's a little bit smaller than 1, so 0.99 minus 2 over 0.99 minus 1 squared. And let's do our sign analysis. So what happens? Is this top going to be negative or positive? Well, it's going to be negative because that's going to 0.99 smaller than 2. And the bottom, we're going to have a negative number, but we're going to square it. So it becomes positive. So do you see that as we're getting closer and closer to 1 from the negative side, we also have a negative over a positive, which gives us a negative infinity. All right. So what about this one? Well, this one is, let's factor it and see what happens, right? Because you know automatically that this has a discontinuity at 2, but we don't actually know if that's a hole or an asymptote, so we need to check first before we just automatically assume that because we're dealing with asymptotes, it must be an asymptote, right? So that equals the limit as x approaches 2 of x plus 2 times x minus 2 over x minus 2. Okay, so then that has the same thing top and bottom, so it cancels out. So that's the same as the limit as x approaches 2 of x plus 2. So that's actually a hole. There's a hole at x equals 2, not an asymptote. So there's a hole at x equals 2. Okay, so let's check the limit. So this is not a limit at infinity or an infinite limit at all. This is just a plain old limit when we're approaching a hole. So remember, once we've canceled this out, once we've simplified this, then we can just use algebra to plug it in, because this function just has a hole here and we need to figure out what's it approaching. What's the actual value of the hole? Well, we put 2 in here for x and we get 2 plus 2, which equals 4. So the limit as x approaches 2 of this function equals 4.